Hi, my name's Jesse and I work at Science World. I'd like to talk to you a little bit about static electricity today. Everything in the world is made of atoms, and atoms have both positive and negative charges. The thing about those charges is that like charges, positives and positives, or negatives and negatives, push away from each other, and opposites attract. Not so true for friendships, but it's true for static charges. So what we can do to move these charges around is take a balloon, just like this. You may have seen this demonstration before, and we're just going to rub it on our hair. What I'm doing now is trading charges back and forth between my hair and the rubber of the balloon. Trading charges back and forth, getting those positives and negatives mixed up. It doesn't really matter which way they go, because different materials will trade charges around in different ways. But by building up an excess of negatives or an excess of positives in the balloon, I can do something pretty neat. We can see those attracting charges with an invisible shelf behind me like this. So you can stick a balloon to a wall, you can use that balloon to pick up little pieces of paper or Rice Krispies, something like that. We call that the invisible shelf because of course it's no shelf at all. It's the static charges pulling the balloon towards the, either the positives in the balloon pulling towards the negatives in the shelf, or the other way, depending on what you rub it on. We can make that demonstration a little bit bigger by using a device like this. This is my Van de Graaff generator, and it works in a very similar way to rubbing a balloon on your hair, except instead of a balloon, we have a big rubber band in the middle, and we have some rollers and brushes in the top and the bottom of the device that are going to help us trade our charges back and forth. When we turn it on, you may be able to hear or even see the rubber band rolling up and down as it rubs against those rollers and brushes. It's building up quite a strong charge in that ball on the top of the device. We can see that with the grounding wand. We may be able to see those sparks or hear the snaps. That's charges jumping through the air, and that tells me I've got tens of thousands of volts of charge in the Van de Graaff generator. Now we can use this to look at the repulsive force of static charges rather than the attractive. Remember, we've got the balloon stuck to the wall with the attractive force of the positives and negatives. And using these pie plates, we can show the repulsive force of either all negatives or all positives. Doesn't really matter. By putting those on top, since they're made of aluminum, which is a conductor, we're going to get the same charge through this whole system, the ball and the pie plates. So, when we turn the Van de Graaff generator on and build up that charge, we should see the repulsive or pushing apart force between the ball on the top and the pie plates. Thanks very much.